Hello everyone, welcome back to another GIS mathematics lecture video. And in this lecture video, I want to continue our discussion on the terminology of matrix algebra by talking about this idea of a vector. And in order to do that, I just want to quickly recap when we talked about matrices and the dimensions of a matrix. So when we did this, we said that a matrix was always row by column. So in this case, 3 rows, 2 columns was a 3 by 2 matrix. And the reason I bring that up is because vectors are sort of a natural fallout of this notation. And what I mean by that is when we're talking about vectors, vectors are basically matrices where either m or n is 1. Okay? And we're going to talk about that more formally in just a second, but I just wanted to recap this notation and this idea so when we talk about vectors, you have it fresh in your mind. So, what are vectors? And I want to be clear here, we're talking about vectors in the matrix algebra sense, right? In the context of matrix algebra. Right? Because vectors show up in things like computer science and physics, and they have slightly different meanings than they do in the context of sort of pure matrix algebra. And so I want to be clear here what we're talking about. So in the case of matrix algebra, vectors are just a one-dimensional matrix. What do I mean when I say one-dimensional matrix? Well, this means one of two things. As I said before, either the m or the n in our dimension notation is 1. What does that actually mean? That means that it either has one row or it has one column, okay? It either has one row or it has one column, or being the key word here. So what does this look like visually, okay? So if you remember back to our matrices before, right, we had an m by n, and in this case we're saying that m or n equals 1. So let's pick 4 numbers. Let's do 7, pi, 1/2, and negative root 2. Okay? If we draw them this way in a line, and we encapsulate them in brackets just like before, right? What we've done here is we've created a matrix that has, right, we'll go back to our matrix notation here, right, it has one row and 4 columns. 1, 2, 3, 4. Right, 4 columns. So this is in effect a 1 by 4 matrix, right? 1 row by 4 columns. We call this a row vector because it consists of a single row. Okay, so this is a row vector. Let's say we took those same numbers, right? 7, pi, 1/2, and negative root 2, right? And we encapsulate, that is a very unstraight line. And we encapsulate them like this, where instead of being next to each other, they're now on top of each other like this, where we now have 1, 2, 3, 4 rows and only 1 column. Right, so this would be a 4 by 1, right? 4 rows, 1 column. Right, we call this a column vector. Okay, so hopefully that makes sense. Again, I'm just going to pause for a second. I'm just going to recap what we've done here. Okay, right? When we have one row and the numbers are laid out horizontally, so each number is a column, we call that a row vector because it's one row. When we sort of rotate it 90 degrees and lay them out so that each number is a row in one column, right, we have a column vector. Okay? Row vector, one row. Column vector, one column. So just like we've done before, right, we have these things visually sort of what they look like. But how do we express them in terms of symbology? I just murdered symbology, but that's okay. We're not going to worry about that. Okay? So with scalars, right, we symbolize them by a lowercase letter. With matrices, we symbolize them with an uppercase letter. With vectors, we use a lowercase letter, but we also put a little symbol above it. So for example, we could do something that looks like this. Right, lowercase letter with an arrow above it. Okay, this is how we symbolize vectors. Now, I want to point out one thing. I'm going to put a giant asterisk here because symbology specific notations change based on who's doing the math and what use case you have. But a good general notation again, general notation in asterisks, right? A U like that tends to mean tends underline tends to mean row vector. I'm going to scroll down just a little bit. And a V with an arrow, right? Again, lowercase letter, arrow on top. Tends to mean column vector. Okay? So let's let that sink in. A single row where all of the numbers are columns, we call that a row vector. A single column where all of the numbers represent rows, we call that a column vector, right? One column, column vector. One row, row vector. Okay? Generally, you symbolize it with a lowercase letter with this arrow on top. And general notation, again, general notation, lowercase u means row, lowercase v means column. Hopefully that makes sense. And as always, if you have any questions, please reach out. Thank you.